Hello and welcome to the OCR Further Maths videos for Pure Core. This is Vectors 5, Lines and Planes. This is video 5.3, the perpendicular distance from a point to a line in 3D. Okay, so here we have a point and a line in 3D, and there's various things that we might want to find out. We might want to know the perpendicular distance from A to L, so from a point to the line. And we may want to know the coordinates of x, which is the foot of the perpendicular. Now, we don't have a formula for this, so we just need to think about it, think about what we already know, and use that in order to help us. What we need to do is start thinking of this point x as being a general point. And then we make this vector from a to x, but we make it perpendicular because that's going to find us the shortest distance. If this vector ax is perpendicular, then x, the foot of that perpendicular, is actually a specific point on this line. And therefore, we can write down what the vector ax is, and using the dot product with the direction vector of L, we know that those two things, when we do the dot product, the answer needs to be 0. So we can then use that to find out this vector and use its magnitude to find out the distance. Now, this sounds a lot more complicated than it is. We're going to go through an example which will hopefully make it fairly straightforward. Okay, so we want to find the shortest distance from this point to the line joining these 2 points here. So if we draw these, so this is the point P, here's the point R, here's the line L that's going to go between both of them. And here's our point A. And we're trying to find this distance here, remembering that we want it to be perpendicular to this line because that will be the shortest distance. I'm going to call this point here X. So first of all, if we want to find the direction vector for the line, we need to find the vector PR. And that is -5, -13, -3. Now going to write the equation of that line L, and it is R is any point on the line. Make it as easy for yourself as you can. You've got these 2 points here. You've got 6, 13, 5 and 1, 0, 2. Which of those is going to be easiest to work with? Let's go 1, 0, 2 plus mu, could be lambda, whatever one you're used to using, times the direction vector. Now again, all of those values are negative. I'm just going to make them all positive because it's still the same direction vector. It's parallel. Okay, so we've now got that. So now what we're going to do is write this point X as a particular point on this line. So it's going to have value 1 plus 5 vector 1 plus 5 mu, 13 mu, 2 plus 3 mu. Now what we're going to look at is this vector here, the vector from A to X. So the vector from A to X is going to be the vector from O to A, subtract the vector from O to X, which is what we found here. So that's going to be 3 minus 1 plus 5 mu, 1 minus 13 mu, and minus 1 minus 2 plus 3 mu. That's using these values here for the position vector of A. So if we simplify that slightly, we have 2 minus 5 mu, 1 minus 13 mu, and minus 3 mu. Okay, now because these two are perpendicular to each other, if we do the dot product of this and the direction vector of the line, we expect to get the answer 0. So we're going to do 2 minus 5 mu, 1 minus 13 mu, minus 3 mu, dotted with 5, 13, 3, and that should equal 0. So we have 10 minus 25 mu plus 13 minus 169 mu minus 9 minus 9 mu equals 0. And when we simplify all of this, we get 203 mu equals 14. So that tells us that mu is 14 over 203. Obviously we haven't finished yet, we haven't found the distance, but what we've done now is find out enough that we can at least find the location of this point X. So this is the first stage of the working out. Okay, so from here we know that this is AX and we've now worked out a value for mu. When we substitute that into here, we get that AX is 1 over 29 48 3 minus 93. And now what we need to do is work out the magnitude of this vector, and that will give us the perpendicular distance. So it's going to be the magnitude of the vector AX. So that's 1 over 29 times the square root of 48 squared plus 3 squared plus 93 squared. So that gives us a distance of 3.61 to 3 significant figures. Okay, thanks for watching this video. The next one in the series will be 5.4, the perpendicular distance between two parallel lines.